Okay, this is question number 1. So calculator is okay. This is from one of those tough tests, 2021. This is a good test. There is a typo in the worksheet you guys have, and you'll see it. I forgot all about it yesterday. The density of a bacteria population in a circular petri dish at a distance r centimeters from the center of the dish is given by an increasing. It's a function is increasing. My goodness. If the function is increasing, what does that mean? Derivative is positive, right? Okay. It is differentiable. Since the function is differentiable, what does that mean? Continuous, yes. F of r is measured in milligrams per square centimeters. Do you see the mistake now? In the table, it should be milligram per square centimeter. So just cross that off real quick, and if you made a mistake or you carried that unit from the table into your answer, we'll just fix it today, okay? Now values of f of r selected, and selected values of r given in the table above. Typically, since they gave us f, they might try and have us find an approximate value of f prime. They might have us try to calculate some type of Riemann sum, and then based on those Riemann sums, a lot of times they ask about over or underestimate, sometimes within the same part, and then a lot of times they'll give us another function, and we have to use that function too. Okay. A lot of times in the table problems, that's where the IVT, MVT come into play, not EVT, extreme value theorem, which would be the max and mins. Okay, so be careful for IVT and MVT. IVT is a height between two heights, or a value between two values, and the mean value theorem is A rock equals I rock, right? Okay. I don't know, I got allergies or something going on. I think I'm getting sick. I don't know what's going on. It's that time of year, man. We just need to get through 2 more weeks, right? I think everybody's thinking 2 more weeks, we're done. For like all your classes. Most of them. Okay, use the data in the table to estimate f prime of 2.25. 2.25 is not in the table. We don't have a function. Can't use a calculator to calculate it. We have to approximate it because they said estimate. And then it says using correct units, interpret the meaning of your answer in the context of the problem. That means you better be talking about almost the whole stem when they say in context of the problem. Be specific. Well, Mr. Bonley, if I said it's the derivative of it's the slope of the tangent line of f at 2.25, no, that's not in context of the problem. That means you have to use the artificial problem, the nouns in the artificial problem that they're talking about in your explanation. Okay? So for part A, what did you guys get? Did you guys go f prime of 2.25 is approximately equal to f of 2.5 minus f of 2, I'm sorry, yeah, 2.25 and 2, yeah, all over 2.25, 2.5, that's what it is, 2.5 minus 2. F of 2.5 is 10 minus 6 over 0.5, 4 over 0.5, 4 divided by halves. How many halves are in 4? That'd be 8. Now, what are the units on this thing? Well, the units of the numerator are milligrams per square centimeter. The units of the denominator are centimeter. So this would be 8 milligrams per square centimeter per centimeter. Or milligrams per square centimeter squared. That's fine also. Okay. So, how will this look writing it out? Let's see here. That would be a distance of 2.25. So, this would be at a distance of 2.25, because that's what R stands for, right? The distance from the center, centimeters, from the center of the petri dish. Now, what did they ask us to do? Now, what are we figuring out? The density of the bacteria population is the density bacteria population. I'm going to say, because I forgot to say bacteria population, say population of bacteria. Or you could just cross that out and then go bacteria population. That's fine. The density of the bacteria population is increasing. Why was it increasing? Because that's positive, right? It is increasing at a rate of 8 milligrams per square centimeter per centimeter. That means if you have this this bacteria in a petri dish, as you're getting away from the center, the density of that bacteria is increasing at a rate of 8 milligrams per square centimeter per centimeter. So it's not like a time period, it's a distance now. As you're getting away from the center, you have more bacteria. The density is increasing on the outside, right? Okay, any questions on that? So make sure you're being very specific. When they say context of the problem, they better be hearing you talk about the density of the bacteria population, because that's what they start the stem with, and that's what it's all about. Okay? 2 points. Part B. The total mass in milligrams of bacteria in the petri dish is given by the integral expression 2 pi integral 0,4 r times f of r dt, or dr. Approximate this value using a right Riemann sum with the 4 subintervals indicated by the data in the table. Now here's the deal, guys. We're used to just seeing antiderivative of f of r dr, right? But when it says r times f of r, that is like an area, right? And then running it through the integral process, you're stacking it up, making volume, which is the weight in milligrams, okay? So if it just had f of r, I think we would be okay. I'm gonna start writing it out. 0 to 4. If it just had, I'm gonna leave a space, f of r, dr, I think we'd know what to do, right? That would be 2 pi times, and then if we use the right Riemann sum, it would be the width of 1 times the right height of 2, plus leave a space, because I'm going to add some stuff in a minute, width of 1, right height of 6, plus width of 0.5, right height of 10, width of 1.5, right height of 18. That would be the integral of, that would be the approximation here, right? But now since they have the r in there, you need the right r also to multiply. So in this case, the right r is 1, the right r is 2, the right r is 2.5, and the right r is 4. Do you see how this problem is totally different than almost every one we've done before, right? But just using your critical thinking skills, we were able to come up with what to do with that part.
So like if it was just like integral from 0 to 4 FR, then you would just do normal, but like since
Normal.
there's an extra step to it, that's why you're adding it.
Yep, that's why we're multiplying it, yeah. And, you know, because this is all numeric, this would be acceptable for an answer, right? But this is a calculator active problem. Please just figure it out. And is that like, you see here, like 289 pi or something like that, or 269 pi? Yep, 269 pi, which is approximately 845.088. Now you'd probably get 1 point if you did this, just did the right-hand Riemann sum, maybe. They might give you all or nothing on this one also. But yeah, this R is confusing, right? So now you know how to handle it. Not important, I guess. Okay, part C.
Do we need units on that?
That'd be milligrams of bacteria. And they're not giving you points for units because they already gave it to us in the problem. Okay, C. Is the approximation found in part A an overestimate or an underestimate? Okay, now we've done this before. The problem is we have not done this with this type of problem, right? If it was just f of r, we know f of r is increasing, right? Increasing, yep. So we're like this, or we are like this. Now, if we're doing a right Riemann sum on an increasing function, overestimate, correct? I think it's obvious. Okay, however, what is r times f of r? If r is a constant, when you plug in r for centimeters, right? What do you know about r all the time? How about r in the data table? What do you know about r? Mr. Brackett, anyways. Just kidding. They're doing some experiment, I think. That's okay. We make a lot of noise in the hallway when we do rockets, so whatever. What do you guys know about R? More specific, that'll help us with this problem. It's a radius, isn't it? Center of the petri dish. What do you know about the radius? What do you know about the radius? Radius. It's increasing also, isn't it? Okay. The radius is increasing. F is increasing. So an increasing number times an increasing number is going to be increasing. Okay. So then we could say, what could we say? The product of R, F of R is increasing. R, F of R. Because before we just talk about F, the integrand in there, right? So R, F of R is increasing. Therefore, overestimate with right Riemann sum. Oh man, mind blank on Riemann. Jeepers, man. Not bad. Any questions on that part?
So if the arm is decreasing, it would be decreasing because it's negative times positive.
I think so, yeah.
But negative is positive.
Positive. Yep. Which maybe they try to trick us next time, but I rarely see this ever. But it was in 2021. That was a tough test. They pulled out all the stops.
It does seem like that. We probably have for 2021.
Yeah, yeah, very low scores.
It's 2022.
It was all right. The density of bacteria in the petri dish 1 to 4 is modeled by the function g defined by g of r, yada yada yada. For what value of k is g of k equal to the average value? Okay. Well, what is the average value of g of r? How would you find that? Well, they gave us g of r. How do you find the average value of g of r? You use the average value formula, right? That'd be 1 over b minus a, antiderivative a to b, g of r dr. So it's be 1 over 3, antiderivative 1 to 4, g of r dr. Okay, use your calculator real quick, find that. And again, guys, I have y1. I have that new equation g of r. I have that in my y1 in my calculator now because it's calculator active. When you guys find the average value, let me know.
Isn't it 9.876?
Yep, and since it's an intermediate value or and value we need to use for something else, let's carry a lot of decimals if we're going to write it down. Okay, so what did you get? We got 9.8. That's good enough, probably. Okay, now we can store that value, right? Store it as a. Then what I'm going to do is I'm going to go into my y1 or my y equals. My y1 is already g. My y2 is now that value, a, that 9.875795. Now, if you forget how to store numbers and don't want to, just carry a whole bunch of decimals with you, okay? You will get the right answer if you just carry enough decimals. How many is enough? The number that is showing on your screen, okay? Find where those two lines intersect, and that is where the average value, 9.875, equals the curve. And that does get us that situation that we've talked about. Remember, if you have some curve, there is the rectangle that is the same area as that curve. Therefore, on that same interval, therefore, where that value crosses, that is the average value of the function, the average height of the function. And what are we getting?
2.497.
Good. Okay, you're getting 1 point for the definite integral, 1 point for finding this intermediate value, then 1 point for the final answer, and that's it. Okay, any other questions? All right, let's go to 2018. That is a better time. 2018. The head of a tree at time t is given by a twice differential function h. That means that h is continuous and the first derivative is continuous, right? Where h of t is measured in meters and t is in years. Selected values of h of t is given in the table above. Use the data in the table to estimate h prime 6. All right, h prime 6 is approximately, okay, 6 comes between 7 and 5. So h of 7 minus h of 5 all over 7 minus 5. H of 7 is 11 minus 6 over 2. That makes 5 over 2. Boom, done. Now, using correct units, interpret the meaning of h prime 6 in context of the problem. Keywords, context of the problem. They're talking about trees and the height of tree. What would the units be for h prime? Well, that would be meters per year, right? So what would we say? H prime 6 is what? What does h prime 6 stand for? The rate at which the height of the tree is changing in meters per year at t equals 6 years. Okay, h prime 6 is the rate at which the height of the tree is changing in meters per year at t equals 6 years. Okay, explain why there must be at least one time t for 2 to 10 such that h prime of t equals 2. That's definitely a rock equals I rock problem. That means mean value theorem. Okay, before we can use the mean value theorem, what do we have to state? And differentiable. Okay, well, h is twice differentiable, so therefore we'll say h is twice differentiable. So h prime and h are continuous on the closed interval. Well, they have open 2 to 10. Well, maybe let's wait to put the interval on just in case we find a different interval. Now, we could say, so h prime exists on this interval and h is continuous on that interval. That could be possible too, okay? Now, let's figure out what the average rate of change is from h of 10 minus h of 2 over 10 minus 2. Well, h of 10 is 15, h of 2 is 1.5 over 8. That's 13.5 divided by 8. Does that equal to 2? So that's not the interval we're looking for. But don't be discouraged, kids. There's other intervals. Go see if there's an interval that you can find, not including 2 to 10.
3 to 5.
How?
Because
What's 6 minus 2?
4,
What's 5 minus 3?
2,
What's 4 divided by 2?
2.
There we go. There's our interval. Okay? I probably would have tried, I would have got rid of 1.5 as the height because I'm thinking, okay, if I have an integer minus 1.5, that's a decimal, right? And all the other subtraction problems, all their differences will be integers. So if they have a decimal divided by an integer, that's the decimal, right? So I'm getting rid of 1.5, so I'm not even include 2 anymore. So I'll just go on to the next one and see what happens. Okay, let's see what it is. Let's show our work that we're actually considering it. Because remember, sometimes we get points for considerations. That would be 6 minus 2 over 2, which is 4 over 2, which is equal to 2. So this is the interval between 2 and 10 somewhere. Okay. Now, Well, Mr. Ballin, it talked about 2 to 10. That's okay. It doesn't have to be 2 to 10. It can be another interval. So guess what interval I'm putting up here now? 3 to 5 inclusive. So that's something you can wait on sometimes, okay? So h is twice differential, h prime and h are continuous on, yada, yada, yada. Then we'll say h of 5 minus h of 3 over 5 minus 3 equals 2. Therefore, there exists some time t, or we can say 1 time t, like they said in the question, on, let's go 3 to 5, remember it's the open interval, such that h prime at that c value equals 2. Now, how would we find that c value? Well, find the derivative and set it equal to 2. Then you'll find your x value, which is that c value. They asked us to do that. We don't have a function, and that's why we're not doing it. That's quite a bit for 2 points. It is what it is. Okay, let's go see what c brings us.
If you're like to find a value for C, how would you like add that in your just rotation? Like instead of saying sometime T, would you say like that?
Well, typically they will say find that c value on that interval such that this is true. Then you'll say there. Yeah. But you have to state that the average rate of change equals instantaneous rate of change on the interval, and then you set 2 equal to the derivative, like exactly like this, and then solve for x, and then you say it occurs at x equals whatever. Okay, part C, use a trapezoidal sum with 4 subintervals indicated by the data in the table to approximate the average height of the tree. What does H stand for? Height. They want the average height. This is an average value formula one because average height given height. So it's definitely an average value. So we're trying to find 1 over 8 antiderivative 2 to 10 h of t dt. But they want us to use an approximation for this. A little sneaky way of adding in that trapezoid sum instead of just a regular old integral. Okay, so now we'll have 1 over 8 times our trapezoidal sum. I'm not going to worry about this. I'm just going to say 1/2. The first width is 1. Sum of the two heights, 1.5 plus 2. Plus 1/2. Yep.
Where do we get the 1/8 from? Why just do the
10 minus 2.
Oh, okay. I see what I did.
Did you get 10 under there or what?
No, I just didn't do the. I just did the from 2 to 10 h. I didn't do the 1/8.
Okay, you probably get 1 point for this problem. You want to get the 2 points for this problem then. Okay, and then second width is 2. Sum of the two heights, 2 plus 6. Plus 1/2. Then what is that? 2 again. And then 6 plus 11. Plus 1/2. 3. 11 plus 15. And then use your calculator, or since this is a no calculator problem, right? Just leave it. It's all numeric, isn't it? That's done. I wouldn't spend much more time going over that. I'd save it for some of those thinking parts. Part D. The height of the tree in meters can be modeled by the function g, given by g of x equals so on and so forth, where x is the diameter of the base of the tree in meters. When the tree is 50 meters, that means g of x equals 50, right? A lot of times we think that's x equals 50. That's not right. That would be diameter. The diameter of the base of the tree is increasing at a rate of, we better write that down. What is the setup for rate of increase of the diameter? That'd be dx dt equals 0.03 meters per year. According to this model, what is the rate of change of the height of the tree with respect to time? The rate of change of the height of the tree. That'd be what? G prime? Right? In meters per year at the time when the tree is 50 meters tall. So what is G prime when G of X equals 50? Well, when would G of X equal 50? I should say, what is the diameter when G of X equals 50? Let's figure that out. 50 equals, what's the function again? 100x over 1 plus x. Multiply and I get 50 plus 50x equals 100x. Subtract 50 equals 50x, therefore x equals 1. So when the diameter is 1, the height of the tree is 50 meters. Diameter is 1 meter, the height is 50 meters. Okay, now we need to figure out what the derivative of the height is at x equals 1. Okay, so go ahead and find the derivative of the height real quick. And the derivative of the height is with respect to what? Time. So you're finding d dt at both sides. Now, because we're taking the derivative with respect to t, it'd be low 1 plus x d high, which should be 100 times dx dt then though, minus high d low. The derivative of low is 1, but it's with respect to t. All over low squared, which is 1 plus x squared. Okay, you can factor out dx if you want to. So you can have 1, or dx dt I mean, minus 100x times dx dt. And honestly, we can just leave that on the outside of the fraction because it's in the numerator as a product. Move it out outside the fraction, that's fine. 1 plus x squared. Well, x is 1, dx dt is 0.03. So that would be 2 times 100 minus 100 all over 2 squared times 0.03. That's all numeric, good to go. But here's the deal. That's 200 minus 100, so that'd be 100 over 4. What is this number, 0.03? What is that? 3 what? Huh?
3%.
3 what? 3 hundredths. Look at that. 3/4. Okay, so a quick way of taking those decimals, making a fraction, will cancel a lot. They make it kind of convenient for us. Okay, so according to the model, the rate of change of the height of the tree with respect to time when the tree is 50 meters tall is 3/4 meters per year. Now, make sure that we have that chain rule, dx dt here, right? Make sure you have that on there. You're not using the same variable derivative respect. Questions? All right, we have 12 minutes left. I'll give you about 8 of them to get the next one done. Ready, set, go. 2016, number 1, calculator active. Be quick, please. Okay, let's see how we did. Now, I did this real quick, first period. So I just kept my answers up here. I think I did it like, I don't know, a couple minutes. I tried to write kind of fast, do the math pretty fast. Estimate R prime 2, right? Obviously, you guys would have read the stem, right? You would have saw there's 50,000 in there. We have a decreasing function. We have water in, we have water removed. We have initial quantity, rate in, rate out, initial quantity. We have all that. We've done that before. Okay, estimate the derivative of R. 2 is between 3 and 1. For obvious reasons, I put these up here. I got negative 120 liters per hour per hour. Liters per hour squared is definitely fine. Okay, if you don't have units, you don't get a point. This is 2 points, 1 for estimate, 1 for units. Part B. Notice what I did. I went back and wrote in that Riemann sum, or not, the integral after I wrote out the Riemann sum. Okay, the calculator is active, so I would definitely want to have an answer here. So this is a left Riemann sum, width of 1, left-hand height, width of 2, left-hand height, yada yada yada. 8,050 liters. Please have your units. Now they're asking, is it increasing, decreasing, or over or under? I mean, well, this is an overestimate because R of t is decreasing. They told us on this closed interval. And the estimate is a left Riemann sum. So a left Riemann sum on a decreasing is an overestimate. Okay? Questions on that? All right. You would have got 2 if you got the overestimate part wrong. So we're already at 4, which is good. Part C, one of my favorites. How much stuff is in the tank? How much water is in the tank? How many bananas on the table? How many people online for the escalator? All right. Initial quantity plus the adding change, subtract the take away change, right? Antiderivative of the change, obviously, we all know that. Okay, so I got my 50,000 plus my antiderivative from 0 to 8, WT dt. That is definitely a calculator part. I wrote down a whole bunch of digits just in case, right? And then it says using your answer from part B. That's my answer from part B. That's what we came up with, so I don't have to figure it out again, right? And why do they want part B? Because you already found that approximation of water removed. Just keep the left-hand Riemann sum. That's fine, because the best we can do is estimate this. Yes, the trapezoid estimate would probably be a better estimate, but it's okay. All right, and so that takes us to about 49,786 rounded liters. Okay, and that's worth 2 points. One is the integral setup, and one is your answer. And then finally, part D, Bell's probably gonna read, but just be real quick. What I was like, okay, they said water removed and added the same rate. So guess what I wrote first? I wrote this first. Then I was like, oh yeah, I can move 1 to the other side. That means 0. That means if I check what's happening at 0, I saw that it's positive. Check what's happening at 8, I saw that it's negative. Therefore, there must be a time where there is a 0, which means they are equal to each other. Does that make sense? And this would definitely be IVT. You better say that R of t and WT are continuous first. I'm looking for when they're equal. That means when the difference is equal to 0. Since we got the positive and the negative, there must be a time between that is 0 by IVT. Okay? Start the volume ones, please, for tomorrow. 1 packet to go. Time flies when you're having fun and doing math. Bye, Bob. See you later.